I'm Mark Kidd, and I'm going to present a bit about my app named Microclimate Explorer. Um, as you mentioned, I'm joining today from the family farm on Little Mud Creek, where it's currently squash planting season, and that's a little bit relevant. We know it's squash planting season because Mother's Day weekend has passed, and the earliest corn is sprouting, and the cicadas have emerged this year. And so we'll get back to this theme of planting time. I enrolled in CodeU because I was interested in pursuing some new career opportunities where technology maybe would be even more central than it has been in the past. But technology has always been pretty important to my career. And I've had roles like project manager, curriculum designer, and technical writer where technology is often a part of like the product itself, but has definitely been a part of my workflow. Another common theme in my work has been opportunities where I can kind of serve as a translator role or a communicator or an advocate, sometimes between two different groups of engineers or users and developers or farmers and media artists. And I think this Microclimate Explorer might be a good example of how I use my experience in different domains to kind of articulate something useful. And I want to start by briefly defining microclimate. And so in agriculture and in many parts of life, even a very small distance can make a pretty big difference in climate. And so sometimes two different fields in the same farm, let alone fields on neighboring farms or farms across the country from each other, can have very different conditions. And so microclimate's kind of the concept for that. And as you can imagine, like it really matters to know some things like when is the best week to plant, or if it's been cold this year, like should we hold off hiring our seasonal help an extra week or two? And so there are many situations where having this kind of fine-tuned data can help make decisions on the farm. And for people working in technology and farmers, this is like an amazing period for weather data. But if you're out there trying to make plans, I've found that a lot of the data available is really granular in a sense that you can put in like any GPS coordinate on the Earth probably, and you might get like historical, present, maybe even like forecast data. But it turns out that, you might be pretty far from weather stations, and a lot of that data has been like parsed through algorithms and now like LLMs. And so this project is a little more concerned with being able to find like granularity in the sense of like a specific weather station or maybe what's nearby me so that I can make, some decisions knowing, where they are on the other side of the mountain. And so fortunately, there is some data like that. It's not as readily available, but it's collected by a couple programs. One's called the Citizen Weather Observation Program. That's some technology that goes all the way back to ham radio. We're going to access that in a minute. There's another one called Mesonet that aggregates a ton of like climate sensors. And there's even more data available publicly through NOAA, this big MADIS database, but it's not always hard to access it, or, excuse me, it's not always easy to get it in a usable form. So that's why we're going to look at this Find You interface, and of course my app itself. So in developing this, I decided that the most important functionality for version 1 would be making it as easy as possible to get GPS coordinates in there so you can go kind of look at data and explore climates. So we have three options now. You can request the location, and on my laptop, it's actually getting like a ISP location. So this is like closer to Louisville than Eastern Kentucky, these coordinates. And option three, though, we can use geocoding via this OpenCage API to type in like a human type name or address. And oftentimes it'll be able to convert that for us into a GPS coordinate. And that, when it's successful, will appear up at the top in the same place as I'm trying to think of the geolocated ISP coordinates earlier. Okay. And I recognize the coordinates have changed. And the next button is active because there are good coordinates in there. And so we're going to go ahead and click that here. And at this point, we can look at some weather stations. There are two options here presently because when we're doing the live database, we're actually scraping a web page with permission. And we don't want to, I don't want to do that 100 or 1,000 times. So The app also has a feature where we can save the web page with some results and parse that. Well, anyway, here's some live results uh, recorded to video from the coordinates that the app found earlier. And so it's parsed that web page, and we've got now some like real granular, sometimes like a little bit older. And every once in a while, you'll see a bunch of like humidity 99% or 1%, and you think this might need to be cleaned. But we know when we're looking at this that we've got real actual weather stations. We can look up these station names and get more details about them and make informed decisions, including like feeding them to our own AI. That's probably in a future version of this. So this software was created using C Sharp with Maui Blazor for the UI and kind of cross-platform potential. I really made use of Copilot and Cloud. It was very educational and helpful for in a variety of ways. I've mentioned OpenCage and the CWOP. The last technology I mentioned is also a challenge. I discovered that Find You, there's like this really unique in some ways weather API is being deprecated. And so parts of it are offline intermittently and they're not going to fix it. So that's a challenge for future development. I also really wanted to draw maps, and that's kind of challenging, or it was a little bit challenging for me. Adding an HTML canvas is probably a future feature that will allow us to draw some maps. Well, I want to thank you for your time, and I appreciate any questions you have for me later. Thank you.